In this video, I'm going to do a simple hands-on example of the set and linked list collections in Java. Let's take a quick overview look at how sets and linked lists work, and then we'll jump right into code. One thing we know about sets is that their members have to be unique, so only one can exist. So we put in the gray, the red, and the kind of greenish beige here. The next time we try to enter a gray, it's going to say, well, that already exists, and more than likely it will overwrite what's there. But there can only be one of each. We also know that sets work very well with big sets of data. So adding an item to a set is an ode to the one operation, which means no matter how many elements are in the set already, it's the same cost to add one more. If the set has one element or 10,000, doesn't matter, it's the same cost to add one more. Same with a contains operation. A contains operation is very efficient. If you want to know if a set contains something, it's O to the one performance, which means it's the same cost to figure that out if the set has one item or the set has 10,000 items or anything in between. This makes it very efficient for a filter. So let's say that we have a collection over here. We want to filter out anything that's in the set. Well, what we can do is we can simply run a contains operation, and if the set already contains that item, okay, no, we're not going to let that one through. And if the set does not contain the item, okay, well, we let that through to the filtered result. Again, set contains the item, no. Set contains the item, no. Set contains the item, no. But then those that the set does not contain go to the... This speaks well to this mathematical Euler diagram that we saw earlier. So we have an intersection, which is where two sets contain the same thing, or a union, which is the combination of all sets, or the difference, which is what one set has that the other set doesn't have. So effectively what we're doing with the filter is we're saying, give me the difference between these two sets. If we're doing a filter operation, we can also consider how we could use a linked list in this equation. So linked list also has very efficient add and remove operations because it's not tied to an index, but instead each node in the linked list simply has a reference to the next node in the list. So if we want to add a node in the middle of a linked list, we simply add it and then connect from the original node to the new node, from the new node to the original next node, and then remove that link that existed before. And notice that all of the others are unaffected. We simply added a new node, two new links, and removed one. Once again, add new node, add a new link to that from the existing node, add a link from the new node to another existing node, and then sever the link between those two previous existing nodes, and the other items are unaffected. So linked lists can be very efficient in adding. Same thing works if we're removing. We simply remove an item, and then we take the two links that pointed to that item, we remove those, and in place of that we put a new link from the previous item to the next item that used to surround the node that we removed. So if all of that is context, let's see how we can implement this in code. First, we need a place where the user can input a string, and then we'll parse that out for any invalid characters. So we'll start with our user interface, and I'll simply add a new component here. And now let's add that attribute to our vehicle as well. Now that we have the attribute, let's go ahead and generate a getter and setter. We'll wire this attribute up to our user interface in just a moment, but first let's think about how we want to deal with invalid characters. So I'm going to make a new class, and we'll make that a singleton, so there's only one object that's around. I'll pre-populate a set with the bad words that we want to filter out. And then we'll have a method that takes a string as input that could contain those bad characters, or bad words. We'll filter out the bad words, and then we'll return back the string that is filtered without the bad words. So new class word validation. Then we'll make our singleton out of it. Remember, that's going to be a private constructor. And a getInstance method that returns an object of this type. So the return type will be word validation. In typical singleton, so we have our private constructor, we have our getInstance method. If we have not instantiated an object out of this yet, we go ahead and do it now, and then we return the instantiated object. As I was recording this video, I realized I missed something on the singleton method. Luckily, though, guess what? It's a recording, so I can go back and fix it, and you'll be none the wiser. The getInstance method should be static, and the word validation variable that it's operating on should also be static. That's just because this is a singleton. So when we're invoking this getInstance method, we don't yet have an object of this word validation type. So it has to be static. We can go ahead and declare our set and then populate that set in the constructor for word validation. Note that set is an interface and hash set is an implementation of that interface, another one being tree set. Hash set's the one that will work for us. And so you see I populated in the constructor with these bad words, and we know that because this is a singleton, it's only going to get invoked one time. So we pre-populate this list once. Now, naturally, we'd likely have a much longer list, and really that list would probably come from a more configurable source, something like a text file or a database as these words change. And this is modeled after something that occurred in real life with me when I was working for a retailer that would put like a lottery code on the bottom of a receipt, and it generated these names randomly, and it wanted to make sure it didn't accidentally generate a bad word or generate one of their competitors' names and put that as well. So, likely this list is going to change over time. So we should make it configurable, but that's an aside. Really, our purpose for this video is to just take a look at how we can use a set to efficiently act as a filter. Now, let's make the method that is going to return the valid string. So you see, we're accepting a string and we're returning a string. Now, ideally, if we're using a filter, the absolute best approach is to use a set as the input and as the output, because with a set you can do a contains operation, and that has O to the 1 algorithm efficiency, which is very efficient. It's really easy to take two sets and either add them together or subtract them together or find out what they have in common or find out what's different. But the trick with the set is it's not ordered. So we could take our string, we could parse it into individual words, put it in a set, but when we get it back out, it'd be in the wrong order. So the next option that we can use for our string is a linked list. Because with a linked list, we know it's efficient to remove a node, and we only have to make basically 2 new connections, and all of the other nodes in that linked list don't change. So we want to get to a linked list, but I'm going to admit this is a little tricky way to do it. We start with a string, and we need to parse it into the individual words, so we can parse based on space. Easy enough. That will give us a traditional old school array, which we can't easily convert to a linked list. So we have to convert it to an array list first, and then we can pass that array list to the linked list. So it's a couple of hoops to jump through, which slows down our algorithm efficiency a bit, but it does get us to the point where we have a linked list that we're comparing with the set. The split function of a string will take any regular expression, but a single character will do just fine. We save that to a local variable. We'll call it words array. Now, you notice that there's a class called arrays, which is like a utility class for arrays. What I can do to that is I can pass to it this traditional old school array, and it converts it to a list of strings. So we'll call this words list. Now from that we can call our linked list, or create our linked list. Now we know that the collections in Java implement the iterable interface, which means that we can iterate over them, or in other words, put them in a loop and shake hands with them. So what we now have is a linked list of words that make up whatever the user has entered or whatever we've read from a JSON file or something like that. Each word is a different entry in this linked list. Now, a couple changes I'm going to make. First of all, I need to give this a generic identifier, so we'll say string on this side and then the diamond operator on the other. The other thing is I'm going to give this a bit of a more descriptive name. We'll call it words linked list. Now, a couple options that we have here. We can iterate over this linked list with a simple for loop. Then inside of that, we can simply say, if bad words contains word, then we want to remove it. And this is an efficient operation because contains on a set, we'll take a look at what we're passing to it, in this case a word, and on a hash set it will invoke a hash code, the hash code method on that object. Remember, hash code is one of those methods in java.lang.object which every object is going to have. And that will generate, not guaranteed unique, but a fairly unique key for that string. And then from there, it's just a matter of asking the set if it has that unique key. And that's a very efficient operation because the set is essentially organized by those keys. So we can go directly to the location where that would be if it exists. Regardless of the size of the set, it's the same time to do that operation because we're just doing a simple mathematical equation. So this is efficient. It is a few lines of code. I could say words, linked list, and then remove, and then pass in that word. And I could do this over and over again. That works just fine, and that's a good way to demonstrate how we can use a set. There's actually another way we can do it too, which is just one line. I can say words, linked list, remove all, and then notice what it accepts. It accepts a collection. And remember, the collection is like that super interface that all of the collections implement. So we could pass in an array list, we could pass in a map, any kind of collection like that. And guess what? A set is a collection. So all we need to do is say remove all and then pass in bad words. And you see in this case, no if test, no looping. There we go. Now, last step is we need to reassemble the original string. Now, string concatenation is inefficient in Java because every time you have a plus operator, it generates a new string in memory. A better thing to use is something called a string builder, which is essentially just holds everything in memory and then generates a string at the end. In this case, we do want to use a loop. So you see that we're adding each word and then we're adding a space after that word, and finally we get to what we can return. And we simply call the words builder.toString, and we're all set. Of course, we should Javadoc this and the like, but at this point I'm comfortable. We're ready to move to our next step. I navigate to the driver form. This is essentially the controller class for that swing form that we saw earlier. Where we are right now is action performed on the save button. So this is where we're gathering the data from the form and we're pushing it into the object. Remember that we made a new field, description. So we'll call that unfiltered string, and now let's instantiate, or let's get an instance of our bad word filter. And now, after line 50, we should have a filtered string, so I can go ahead and set this on our vehicle. Let's go ahead and update the user interface with this newly filtered string. And finally, let's set a couple of breakpoints on this new work that we've created, and let's watch it in the debugger. So we'll say Sonic with 10,000 on the odometer, 15 miles per gallon, 10 gallons of gas, and I'll say, I love this car, gosh darn it. Now, a couple things I want to point out about our filter if we were doing this in real life. First of all, when we're comparing strings in Java, capitalization is important. So we'd likely want to lowercase everything that we're putting in the set and then lowercase everything that we're testing against the set. Also, remember we're splitting on spaces. So if we have a bad word and then a punctuation like a comma or an exclamation, it's going to count that punctuation as part of the word and it's not going to identify that word in the set. So we could probably use some regular expressions to strip out that punctuation. But nonetheless, we're not really worried so much about building a filter as we are about learning about sets and linked lists. So I think we're in good shape now. So gosh darn it, those two words are part of our bad words. Let's see what happens when we go ahead and hit save and the debugger kicks in. Notice that we have our unfiltered string. I love this car, gosh darn it. And now we're going to step into our filtered string method. And so we step in here, we see we're first going to parse the unfiltered string into an array. And notice that that array has what looks like about 6 or 7 components to it. So we convert this array to a list or an array list, one that we're more familiar with. Okay, yeah, 6 components to that. We take a look at that. I love this car, gosh darn it, just like so. Now we take the linked list and we tell it subtract from itself whatever we find in that set. So I expect that the words linked list, once we do this remove operation, which I'm about to do, should shrink from 6 elements to 4 elements. And sure enough, we see that it now has 4 elements. I love this car. So we successfully are able to take that linked list and say just remove all the bad words out. And now we're at the point where we're going to iterate over the linked list and we're going to reassemble and return that string. And now back to our UI controller class, and we see that filtered string does not have the bad words, and indeed we're setting the description after filtering it. We'll go ahead and let that run. And sure enough, our user interface is updated. I love this car, just as you see here. So in this video, we've seen two of the Java collections framework, the set and the linked list, and we know where they have some efficient operations. With the set, a looking up an item is very efficient. It's O to the 1 performance. And for a linked list, adding or removing an item is also an efficient operation, generally also an O to the 1 performance. What that means is no matter how big the set is, no matter how big the linked list is, doing those operations is constant. The time doesn't vary based on the length of the collection. Now, there are a couple things that vary based on the length of the collection. First of all, when we do that remove operation, it does have to find those items in the linked list. So there's a bit of O to the N there. Also, there's a bit of O to the N when we're reassembling that final string, because once again, we have to iterate over that linked list. So O to the N means every additional item in that linked list means one additional operation. And in that case, it's the iteration to put together that final string. So yeah, those, I don't mean to neglect those, but the actual removal operation in the from the linked list and the contains operation from the set is very efficient even over large data types. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.